Okay, guys, welcome back. Just a quick announcement. The midterm exam is going to be Tuesday, June 22nd. And the exam is going to be from 6 p.m. up to 8:30 p.m. Okay? And the reason behind that, because we do have a few students are working during their class time. Okay? It does mean that you need to spend the entire time to do the exam. Maybe most of the students expect that you're going to finish the exam within the first hour. Okay? Make sure that when you submit your exam, that you have submit every single answer sheet, especially for the student. They're gonna use like external piece of paper to write their answer. Then sometimes you're gonna forget to submit to upload to say one page or few pages. I'm not gonna accept that. So if you reach me out after 6 hours, 8 hours, or whatever I said, I forget to upload one, or there's one missing sheet for the answer sheet, so I'm not gonna accept that. Please double check your submission. Once you upload your solution, double check and see whether your solutions, all the papers are there or not. If not, you can upload again. I give you a chance to upload, unlimited chance in order try to upload your answer. And I'm going to grade the last of the final one, okay? There is no need to write the question and the answer. Just say, for example, question 1.1, this is the answer. Question 1.2, etc. There is no need to type the answer, then after that, send me an email and said, I don't have time to finish the exam. I know the questions. Sorry, there's no need to write the question, not the answer, okay? The answer, yes, you have to. I do know the questions, so there's no need to tell me the question 1, question 2, blah, 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 okay? The other thing, hopefully by the end of the day, expect for me to receive an email that contains like a feedback about the phase 1, okay? And I guess since I didn't reply to you, didn't give you the feedback on time, so it's okay. I can give you maybe a few extra days to finish phase 2. So maybe give you 2 more days to finish phase 2 if you want. Right now, the phase 2 is supposed to be June 16. Yeah, 17, sorry, June 17. So maybe June 18 or 19. If you need time, it's fine for me in order to finish, submit the phase 2, okay? So back to the class. So last lecture, we start looking at the introduction to the SQL. So starting looking, how can we write my SQL query in order to modify generally speaking, to access the data, to create the table, then access the data. Today, we're gonna continue our discussion about the SQL. So I'm going to talk about the aggregate function. I know we looked at this one last time, but just try to start from this point. Then after that, I'm going to show you some command or SQL. How could you perform the same modification to modify the data, all the content in the data. Aggregation function, as we mentioned before, is like what? Is a set of functions that allow us in order to perform a set of, let's say, a calculation on a set of tuples, okay, or group of tuples, and return a single row, okay? Generally speaking, most of the database management system provider, okay, is going to provide all the standard SQL aggregate functions. So what we talk about right now, this is the standard SQL. They have the description. They said, in order, those are the set of functions, say the aggregate function that we can use in order to help you in order to perform the aggregate function. The average is going to return, let's say, the average value. The count is going to allow me in order to count, let's say, the number of values. And we do have two different versions of the count. The first one, count to start, that means include even if you have a tuple, for example, relation R, and the relation R contains, for example, A, B, C attributes, and we do have some tuple is going to have a null value, for example. So if you set count star, so the tuple that contains the null value is going to be included as part of the result. We do have another function, say, I'm keeping function, functional dependency because there's another subject. We need to talk about this one later. Anyway, ignore this one. The other aggregate function is called the same maximum and the minimum, which allow me in order to return the maximum value of the minimum value. Okay, so we do have another aggregate function with the sum, which return the sum of the distinct value. And back, by the way, to another one is called the count, where they have a set of attributes. So when you talk about the count, which allow you here to specify what the attribute that you're going to use in order to count based on this attribute. And here for the count, you see that we can do 2 different stuff. The first one, we can specify whether it's distinct or not, okay? As you mentioned last lecture. So give you an example. Assume that you count the ID or count the distinct ID. Let's change this one to the count, for example. What's the difference between the count to say the department name, and if I said count to say distinct the department name. So assume in this relation R, we do have one attribute, it's called department name. And we have, for example, name, maybe ID. I mean, we have a set of information, okay? So you can, for example, we have ID1, ID2, etc. We have different names, and we have, for example, few students. For example, this R contains information of the student that belongs to the computer science, and maybe one student contains, belongs to the neurology math department. So when you said count department name, in this case, the system is going to say, okay, 1, 2, 3. The result is going to be 3. Okay, if you said count distinct department name, that means the system is going to double check and say, first of all, I need to eliminate the duplicate based on the department name. Then after that, I'm going to count. So in this case, I'm going to say only 2. We have 2 unique departments. So it depends what kind of operation you're going to perform. Okay. Then after that, we want to show how can we use the aggregate function in general. So for example, if you said, find the average salary of the instructor in the computer science department. So in this case, there is no need in order to divide the data into groups, okay? Why? Because I said, I need just the average salary of the instructor in the computer science department. So the simple thing you're gonna perform here, do what? I'm gonna say select the average salary from the instructor where the department name is equal computer science. So if you take a look to the order of the execution here, you start first. The system is gonna be evaluated as the following. First, take a look to the form. This is the first time we're going to execute. That means you access the relation instructor. Then after that, we're going to evaluate the where class. So that means starting filter out the tuple that doesn't satisfy this condition. Then after that, now we start compute the average salary. So in this case, you're going to perform the select class. So in this case, all the survived tuple from the where class, now we need just to compute the go to the salary, compute the average salary, and the result will be something like this. So we have average salary, okay, and the value. So we have only one tuple and one column and one tuple. Actually, the value or the title of the column is not clear. It depends on the database management system you're going to use. But I guess most of them are going to do something like this. Since you didn't give me the name of the attribute in the result, by the way, so most of them are going to do something question mark, for example, column. Question mark, and this result is going to be, for example, 5 point whatever point. Assume this is the average value. Okay, you can use this one as you mentioned last time. You can use different name. You can assign a name or alias to this attribute after you perform this operation. So you can say in this case the average salary here. You can say as here, for example, average underscore salary. So here it looks like you're given you say, during the execution time, or during when you present or display the result of this query, now we're going to use the column and give the name of the column for the average salary as this. Okay, so if you said here, find the total number of instructors who teach course in the spring 2018 semester. So in this case, it looks like I'm interested to the number of instructors. So the teach course. So this day, you go X way to the teach. Why you need to add to the teacher relation? Remember we said this one when we start looking at the relation algebra. We've said that you need to understand the schema. You need to have the schema in order to decide database schema in order to figure out the way how could you execute your query. Okay, which relation you're gonna access to? Okay, whether you're gonna access one relation or the general one table or two tables or more than one tables. Here the teach that contains information about the list of all the courses that are taught by every single instructor. So that's the goal that I need here. I said all the total number of instructors. So select. I'm going to talk about the distinct later. Count ID from teach where the semester was spring and year 2018. So we know the filter out of the tuple that satisfies this condition. Then after that, we need to have a distinct. And the question here, why we need a distinct here? Because I need just the number of instructors. So there is a chance might be one instructor teach more than one course. So if I didn't say distinct here, for example, assume in my case, I'm teaching CS425, I'm teaching CS525, I'm teaching CS458 in one semester and more. So you see that in this case, if you don't do distinct, so I'm gonna count this is my ID, for example, 100. You see that my ID 100 is gonna be counted 3 times. So it's not going to give me the accurate result. In this case, I need, since we have one instructor to be counted one time, that means there is no need to repeat count this one, or include this one in any further computation or the further computing. So in this case, we have to use a distinct. Otherwise, we are not going to get to the right result. Clear? Find the number of tuples here, either going to sound, count star, because I want to make sure even if you have a, let's say, tuple that contains null value is going to be included in the result. But since we have a primary key that's enforced in this relation, this means we don't have, let's say, primary key is not allowed to have a null value. So in this case, you can say select count star, or you can say select and count to say any attribute you're going to perform here. Oh, the number of tuples. The nice thing, you can use, for example, the key they use as a primary key. That's another thing. They can say count and the ID. Assume that the ID is the primary keys of this relation. So I have different ways how to perform that. Another thing we looked at that time, last lecture, we often use, the aggregate function with the group by class. So this means you're going to organize the data, or you say, of course, the class goes in the select. Okay, so we have aggregate function that we're going to be in the selected statement. So I'm going to use a group by in order to what? In order to divide the result set into groups of tuples, and then the aggregate function is going to be perform a calculation on each group. For example, I'm looking for, we covered this one last time, remember? So let's say I'm looking for, let's just need to have an example, I guess, this slide. For example, I want to have, I'm looking for an example, yeah, here. What I need from you to find the average salary of an instructor in each department. So it looks like what I need from you, for every single department, you need to compute the average salary. So in this case, can I use this one selected from where class? No. I need to have a group by. So that the structure looks like something like this. We're going to select. What I need to do here, I'm going to say department name and the average salary here. From the instructor, do you have where clause? I don't need it in this case. Go by the department name. So the order of execution or the evaluation in this query start always from the front first. X is the relation instructor. Then after that, based on what you have here, go to the group by. 2. Divide the data based on the department name. And that's what we did. You said one department, there is another group, there is a third group, and the fourth group, fifth group, and sixth group, and seventh group. So that's the way how to perform. Then after that, now go to the select. It's going to be this order evaluation based on the SQL query that I have in this example. Then now, for every single group, you need to compute the average salary. Why we need to have a department name here? It's going to be part of the select here. If you don't give me the department name here as a result, it's fine. Doesn't mean that you have to specify this one in select, but you have to use this one or specify the group by attribute in the group by class. But there is no need to have it in the select. But if you do that, remove the group by, so we end up, we have something like this. Can you understand what the average salary for the first one, which department? It's not clear. So that's why it makes sense in this case, I need to add, say, this attribute here. Otherwise, it's hard for me to interpret, the result set that I have. Okay? Generally speaking, the order evaluation is to give you like a from where class, complete from where class. For example, if you have select something from whatever, okay, where we have a condition, okay, let's say group by, something like this. So the order of execution or the evaluation can be what? First to the from, second to the where, 3 to the group by, then 4 to the order. To the select. You see? So the order first from, then after that where. If you don't have it, then after that go to the group by here. Then after that go to the select, and etc. So every time we use one class or this condition, add more extra to say, class to the SQL statement, I'm going to give you the order of evaluation. And the order of evaluation is very important here. Okay? So, for example, here, can I use the average salary here in the group by here? Yes or no? In order to say yes or no, it depends here. Okay? So, Here, the average salary is going to be what? It's going to be computed after I evaluate the group by. So that means if you said group by, for example, let's see, yeah, write this one. It's nice to write this one. As you select a star from the data, structure group by, let's say, just for example, okay? Or let's do something different. From the structure, I'm going to add where, let's say, the average salary greater than 2000.09, something like this, 00. Can I do this one? No. Why? Because the system is going to say, okay, first I need to go over the form. Second, I'm going to evaluate where. When I take a look where, average salary, do we have this attribute? This is going to be known at this time? No. It's not doesn't exist yet, because this one is going to be in the selective clause. Since I didn't execute the selective clause, so I cannot use this variable. Okay? So this one is not working because this one is going to be appears later. You see the order 1 from, 2 where, 3 group by, and 4 I'm going to talk about the select here. So here, yes, the average salary is going to be available here. Can you use this one in the order by? Yes. Remember when we said order by? Order by is going to be executed after the select. So yes, okay, we talked about this one last lecture. Another thing, for example, if you have include, for example, something like this, select department name, ID, average salary. In general, attributes in the selected clause outside the aggregate function must appear in the group by list. So this means if you have any attributes listed in the selected clause, and those attributes is not part of the aggregate function, it's outside of aggregate function. That means I don't use them in any aggregate function. So for example here, the salary, it's outside of aggregate function? No, it's attribute, it's fine because I use in one, let's say, an aggregate function. So there is no need in order to put this one in the group by. But how about the department name? Yes, I already did put this one here. How about the ID? The ID is not used in any aggregate function. So in this case, the system is going to say it's not allowed based on the SQL standard. And the reason behind this one, because there is no unique way in order to choose which ID value to output. Because for just take a look here. If you go by based on the department name, and you say I need to display the department name and the ID here, comma, the system is going to say, okay, for this one, for this department, which ID you need to represent, this one or this one or this one. Even if we have only single attribute or single tuple. This is the structure that said since you don't include this one in the aggregate function, this one must be listed in the group by, otherwise you are not allowed to perform this operation. Clear? Now let's take a look to something different here. How about if you try to perform, let's say, perform evaluation after I perform, or let's say, compute the aggregate function. For example, remember that the example I give it to you is that, for example, let's say I want to display only the department name they have, their average salary is greater than a specific value, or let's say based on the condition on the average salary of this department. Not all of them. This back here. Assume that if you wanted to display only the department there where the average salary is greater than 80,000. So in this case, can I use where clause? No, because at the time when you try to use the where clause, I didn't compute the aggregate function yet. So how can you perform this one? We can perform this one using specific clause. It's called having, which allow you in order to evaluate, okay, or perform, it looks like where clause somehow or condition after you perform the aggregate function. Okay, so that can be having here. Take a look at the structure of the having. So select from where, go by, and having. So the order of evaluation and execution is going to be as the following. First from, second where, always this is the order evaluation. Then third, based on the data that I have, group by. Then after that, this interesting thing here. The group, when you perform group by, that means here you're going to compute the aggregate function. It's going to be computed here with a group by. Okay? Then after that, you can do having. Then after that, we can perform select. Remember, again, I emphasize it, when you do the group by, that means now we're going to start compute the aggregate function. Okay, so this is the way how to translate this one using relational algebra. First, you perform X, whatever form, the simple thing we do Cartesian product, all right? Then after that, perform the selection based on the where clause. That's what we did here, based on the predicate in the where clause. Then after that, you're going to perform what? You need to do the aggregate function, which is that's what you perform here. That's group by. Then after that, I'm going to do what? I'm going to perform the selection. Having, by the way, it looks like you do where clause, but it's not where clause. I need to just filter out the tuple that satisfies specific condition. Okay? That's what we did here, based on the having. Then after that, you're going to perform the selection. So the end, so project whatever tool going to be part of the result. The order of execution, evaluation, very important. Okay? So, can I use the column alias that I just to say introduced in the selected clause in the having clause or not? So let me give you an example first using the having. Then after that, there's a good go back to this one. Okay. So by the way, this is the difference between the where and having. Where that means you can perform the evaluation or filter out a tuple based on specific predicate after you access the relation, after from. So this means if you want to perform an evaluation or filter out a tuple based on the aggregate function, you cannot use this one in the where clause. So the only option right now using the having clause. Okay? Sorry. So assume that you have the following example. Let's find the names, the average salary, all the departments whose average salary is greater than this number. So in this case, I need to compute the aggregate function, right? Then after that, based on the value of aggregate function, which is going to be the average salary, I'm going to check whether it's going to be part of the result or not, based on the condition. So that's what we done, right? This is the solution here. Select the department name, I get the information, and the average salary, this is the average salary, and specify specific name, just an alias in order to make sure that the outcome of this query is readable. I don't have the column, as you mentioned, you're going to end up have something like this. Okay, because as you mentioned, depends on the database management system, some of them or most of them are going to use something like this. It's going to be the name of the relation. For the attribute name, that doesn't have a name, especially for the aggregate function. Or when you perform any, let's say, mathematical operation of the attribute. For example, when you say salary divided by 12, if you don't specify what the name of the attribute or the result set, so the system may, most of the case, do something like this. Okay? And we don't like it. Anyway, so select this relation, or this data, from the instructor, where, do you have a where clause? I don't need it, so there is no need here. And set group by the department name. So in this part here, what we're going to do here, we're going to do the same thing that we did in the previous slides. Just compute the department name and the average salary per department. Now, after I compute this one, I need to figure out something else. I need to make sure that not all of them is going to be part of the result. Only the one that average salary is greater than 42,000. Okay? So in this case, I need to say having the average salary is greater than this number. So again, the order of execution, first of all, to group by. Here you're going to compute that. So here we can compute the aggregate function. Okay, going to be computed with a group by. Then 3 is going to do what? Actually, 3 is going to perform, do the having. Then after that, 4 is going to be based on the select with the project the number. So the question to you here, guys, can I do something like this? Instead of using average salary computation, I'm going to use this alias. So what do you think? Is it okay or not? In other words, can we use the column alias that we define in the selected clause in the having clause or not? Check the order evaluation. See whether you're going to evaluate select before or after having. If before having, then yes, you can use it. If no, after having, that means you can't use that. You understand me, all right? Good. So what do you think? Can we use it or not? If I execute this command, what the system gonna say? Why? Because it's gonna say the average salary doesn't exist yet. When you say average underscore salary, I use the alias for the average salary. Why the order? 1, 2, then after that, I need to perform having 3. When you reach this point, the system is going to say, you're going to use average underscore salary. Do you have a variable attribute under this name? No. Do you have a variable here? No. It's not exist now. So it's going to give you an error and going to tell you this doesn't exist yet. Then after that, you're going to execute whatever the select. So in this case, we cannot do this one because this one is going to be exist later after we execute or after you perform the having. Okay? So again, having going to be after you perform aggregate function before select. Good. We talk about the null value, okay, in the aggregation in general. So if you said select sum the salary from the instructor, this is going to just give you total salary that we have. And also here we can say as, for example, whatever, we say total underscore salary as the name of attribute in the result set, okay? If there's any tuple that contains the average or the salary has a null value, which it might be, yeah, it's not primary key, so maybe it depends on the design that we have. So in this case, the system is going to ignore this one. It's not going to be part of the result. So only is going to take a look to the null amount, which is going to be part of the result. What if all the value of the salary is going to be null value? So the system is going to give me the result as a null. Okay, so if we take a look at the relation instructor on all the salary attributes, all of them have null value. So the result of this command is going to be null. Okay, this is the result here. We talk about the count star, the count specific attributes. So in this case, if you said count star, if there is any tuple continues to say null value, the system is going to count this one as a valid tuple because it needs how many tuples stored there. Okay, if you said count that contains only null value, for example, so the result is going to be performed what? I'm going to take the count with a specific attribute. So the count is going to return 0 in this case. Okay? I didn't have a tuple. But if you have a count star is going to ignore, is not going to ignore the tuple with the null value. So include it as a part of the result. If you sleep, please wake up. This is a very important part in order to, we need to talk about this one today. Nested subqueries. It's like similar to the nested loop somehow. So subqueries in general allow us in order to construct complex query, make it more complex. Okay, so in this case you are going to pass or figure out or find out a way in order to pass to say it looks like we have two queries, query inside the query. Assume that select, and they select from where this one query, and beside this one maybe you have another query. So we need to find a way in order to do what? In order to take the result or the pass, the result from the first query or the, let's say, the inner query into the second query. Okay? And it's going to be only in one query. So again, the subquery is the query nested inside another query. So you have a select from where, and maybe you have subquery inside the select, maybe you have another subquery inside from, or maybe you have another query inside the where class. So what does that mean here? You have a select from where, and maybe you have the from, and within the from you're going to say select something from where and etc. So you have another query inside the query. How can you evaluate this one? How can you work with this one? So I'm going to go with many details about this one. First, I'm going to show you that how can you use a subquery within from class, where class. How can you use this one in the from, and how can you use this one in the select. And you're going to see sometimes you don't need the subquery, okay? Because there's some other way you can write your query in order to get the result that I'm looking for. But sometimes you have to. This is the only way in order to write an easy query. Of course, it's going to be complex, but it's going to be trying to solve, let's say, complex request. Okay? So, a nested subquery is it's like a query inside another query. Okay? So, a common use, as I mentioned, is going to be what? Of the subquery is going to be to perform tests. test is for the set membership. So somehow you can specify, for example, whether something, or say you can select from where, for example, the ID is in another subquery. So test this whether this ID is going to be a member of this subquery, list of the IDs that I can compute within the subquery or not. I'm going to show you how to use this one, but it's just I want from you to imagine what do you mean exactly with the subquery. Okay, that's one thing. There's a test of a membership, set membership tests. Okay, whether you can use n or maybe the ID or specific attribute not in the set of attributes or set of membership. Okay, use the subquery in order to perform, let's say, or make set comparison. So in this case, you can compare a value to the set of the values. For example, whereas, for example, just for example, okay, the salary is greater than or equal a list of salaries here, something like this, or not equal, or less than, or something like this. Okay, that's what we're gonna use in the, let's say, where class. Okay, and let me generalize this one, then after that go more deeper. Okay. Also, you can use this one whether the value or some value in the set or not. For example, you can specify, for example, D is gonna be, let's say, greater than any, or let's say all, or some value that's stored or can be computed by the subquery. I know it's confused a little bit, but that's what we're planning to do here. So query inside another query. So the goal here, we have to find a way in order to pass the result of the first query into the second query. And all of them are going to be in one big query. Okay? So I'm going to take a look to the where class first. With here, the way that when you perform the subquery here, you're going to have select from where with the original query, where, and here you're going to say, for example, something be operation. And here we have a subquery, select from where. And this kind of attributes can be one or more attributes where the ID is in, not in subquery, something like else, or whatever kind of operation you can perform here. Okay? We can use the subquery here to select the class. And here it's going to generate, to say, only single value. We're going to show you the different ways. I will give you some examples. Then it depends on you whether we're going to decide to use them or not. How can you execute subquery in general? I'm going to repeat this one many times, okay? So assume that we have one select, whatever, something here. And here we have, let's say, subqueries, where whatever n something and select from where. It looks like a nested loop, okay? So the first thing you're going to be evaluate, the SQL is going to take a look first. I'm going to execute the subquery. Select from where. So the inner loop or the inner subquery first. Execute this one, get the result. Then after that, get the result of the subquery and pass it to the outer query. Whatever result that you have is going to be here, pass to the outer query. So here you're going to have, for example, where B, for example, N, and the list of the subquery here. Remember, this is a query, yeah? So SQL query is going to produce result set, a relation. It depends whatever attribute is going to be there, and the column, how many columns, or let's say how many tuples. So compute first this one, then pass this one to the outer query, and now execute the outer query and see whether it's going to be true or false. It's going to be like here as a predicate. Let's do this one at a time here. Those are what I've said here. We have widely used. We have a direct comparison with the Scala subquery result, or maybe set membership tests with the most common one. We can use n, whether attribute is n or not n, and you can specify where exists result or not a result. I'm going to see how can we exist or not exist. You can use, for example, set comparison tests. We can by the way, any and some is going to be the same. Okay, and all it depends on the whatever database you're going to use here. So here I'm going to talk about the sum. We're going to see the implement. It's going to be implemented as any in the Postgres. Okay, you can say unique or not unique. This is based on the standard. So I don't think there is any database management system implement unique and not unique. But we are going to show you a way how can you do this one without using this specific keyword. Okay. You can use this one in the select from where, and also you can use this one in the having class if you want. Let's do this one at a time. I'm gonna see how can you use the subquery, which allow me in order to perform the set membership with the first one. Okay, how can you do that? Let's do this first. So in this case, I'm gonna do what? The SQL allow us, or give me a chance, a way in order to test the tuple from the membership in the relation. So we can use n. When I say n, and here there'll be the subquery here. Select from it. So you have to execute this one, give me a result with another relation. So you can specify, for example, whether ID or B is a member of this relation or not, that A produced by the subquery, or not n. Okay, let's have a simple example. By the way, I'm gonna give you like examples, and I'm gonna answer this question examples, maybe for example, with a complex way. Maybe some of you are gonna say, okay, I do have an easy way. So the goal here is not for the easiness or the performance. The goal right now, just to give you an example, how can, or illustrate the way that how can you use this whatever clause or whatever feature in the SQL. Okay, but again, maybe there's many other ways. It's easy to compute or easy to answer this query in a more efficient way. So remember the question we just did before. Find the courses, for example, offered in the fall 2017 and the spring 2018. So the simple one to do that is what? Can you do this one using intersection? Remember this one? You said select, for example, all the data from what? From the section and where I think the course or semester equal fall and the year equal 2017. And we have another query. We'll select all the courses got over the spring and 2018. Then I perform intersect between them, right? Because I need to make sure the course is going to be offered here and offered there at the same time, okay? And offered in two different periods of time, okay, or sections. So in this case, I'm going to do this one different. I'm going to use this one using the subquery. So I'm going to say here, select the course ID from the section. Why you need to access the section? The section contains all the information about the course offered, okay? And give me more details about these courses. Why I don't need to have, for example, access the course relation here? I don't need it, because do we need to access the course relation? No. Why? Because all the information that I need is already exists in the section relation. Oh, in this case, if they ask me and said, I need the title of the course, so in this case, you have to access the section, the course relation with the section order to find out the course offered at the time, and you need to display, say, the title, okay? So anyway, since we need just to have the list of course offered in the fall 2017 and I know what's happened here. Okay, I'm back. I just touched my iPad, so everything went black. Anyway, so in this case, let's take a look at the subquery. What you need to do, take a look at the first one here. So what's the result here? Select the course ID from the section where the semester spring and year 2018. Here is going to be listed all the courses offered in the spring 2018, right? So what's the result of this one? The result would be something like this. It's going to be course ID, and it's like a relation, and here contains all the list of the courses that offered in the spring 2018. All right? So this one can be executed first. It's a subquery. And the result can be passed to the outer query. So here instead we have n, we have subquery. This subquery can be substituted with the result. So it looks like we have n, we have result set, or we have a relation that contains the course ID that satisfies this condition, which is going to be spring 2018. So now I need to execute the outer query. The outer query is going to say what? Select the course ID. I'm going to get back to the distinct, okay? From the section where the semester equal fall and the year 2017. Ignore the end for a while, okay? So this part is going to do what here? Let me have a different color here. This one is going to produce the list of the courses that offered in the fall 2017, right? I need to intersect to see how can you use the set membership. And this course, that means for every single tuple here, again, that satisfies this condition, each one, I need to take the course ID here value and make sure the course ID value that exists here is going to be exist here too. And that's what I said. It's the course ID that for this tuple going to be part of the result must be in. In that means inside must be a member of this result set. So if I found the course ID that offer in the fall 2017 and offer it in the spring 2018, great, that's what I'm looking for. Clear? If you understand this one, then the rest is going to be easy. Because you need just to understand the logic. Then after that, it depends on what kind of query. Sometimes you have to perform or answer the query using this mechanism. Okay? Clear? I will assume it's clear. Make sense? What if I change my way, the question, and the query said, I need the course offered 2017 fall, but not in spring 2018. Let's do using the subquery. Of course, in order to perform this one, you can use except. That means you're going to have to query, or part of the query, find the course offer in the fall 2017, but not in the spring 2018. So I take all the list of the course of 2017 and perform except with minus. We didn't have minus, yeah? And the SQL and the relation algebra, yes. So this way, except the course that over the list of the, let's say, the course over the spring 2018. So the course ID, if the ID course exists here but not here, this is going to be part of the result. Let's do this one. The subquery, the same thing. It's going to come with all the course over in the spring 2018. And this is simple, okay? You do this one, you parentheses, okay? But we have put the subquery here. Then I said here, the course ID from the section where the semester equal 4 and let's say the year 2017. Just go over this one. This is going to produce what? The course offered in the fall 2017. Okay? So in order to have a tuple, and let me go over the end here. Color. And the course ID for this one, by the way, the spring 2018 going to have the course ID and the list of the course that satisfy this condition. Okay? And here it's going to have a course ID. I'm lazy guy, so I just use C. Okay? And the list of the course that satisfy is going to be for 2017. Then each of them is going to be part of result F for every single tuple that satisfies this condition. I need to check this one. This one is not a member of this subset. So that means this course is going to be offered here, but not offered the spring 2018. So this one is going to be part of the result. Clear? So similar to what we did before, but here different what we're looking for. That's the way how can we use a subquery. Of course, we have another way. We're going to talk about the correlated subquery with a different story, a few slides. But right now, just I want to make sure that we are on the same page. Okay? So the question here, why do we have distinct here? Why is the distinct going to be necessary? The same thing when you said you need to compute the number or come up with the number of instructors they have taught any course during, for example, whatever specific period of time. If you have one instructor perform this one, let's say, multiple, or teach more, or let's say, many courses, I need to count this one only one time. So the same thing here. I need only the list of the course offered in the, for example, 2017, fall 2017, and spring 2018. For example, do you think you need from me to say CS425, CS425, CS425 many times? No, just repeat this one only once. That's what I want. Okay? I didn't ask you, for example, how many times this course offered. Oh, that's different. So you need to count. And you need, in this case, count, the course ID without distinct. Right? But here, I just ask you the list of the courses. So there is no need to repeat them. Okay? So the distinct here is very important. In order to give me, or necessary, in order to give me a result that makes sense. In order to don't repeat the course because the list, only they need the course of the list here. So by the way, the subquery can return 0 or more tuples. It depends on the query that we have. Okay? What else here? So here, we talk about the n and not n. How can we perform this one subquery? We can use this one as on enumerated set. What does that mean here? Instead, use this one here let's say use subquery in order to produce the result set. You can, for example, you can create a result set by yourself. You can say, for example, I'm looking for all the instructor, name of the instructor, whose name is neither, let's say, Mozart or Einstein. Okay? So in this case, you can say, select name from the instructor, distinct. I don't need to repeat the instructor names. Maybe you have the instructor have the same name, so you need to list only ones. Where the name of this instructor, for example, not n, and here you can specify Mozart, Einstein. So the system gonna check for every single tuple of the relation instructor. And this one gonna be part of the result if this one gonna be, this one gonna be evaluated to the true. That's the meaning here. Yeah, must be evaluated to the true because it's one predicate. Clear? Okay. Now let's take a look to. I see we use the set comparison based in order. Set membership in order to help me in order to test membership in one attribute. Can we do this one with more than one attribute? Yes. Right now, I said maybe the department name, maybe it said course IDs, and can I say, for example, course ID, course name, whatever title, whatever set of attributes in one? Yes, you can do this one. So assume that I want from you to find the total number of this student, and you said distinct student, who have taken course section taught by instructor with ID equal 10101. Okay, let's do this one. So you need to list all the total. By the way, you need to understand the query first. If you understand the query, then it's easy for you. The only thing you need to find out which attribute, or let's say which relation can be I need to ask in order to compute this query. Okay, so here when you say the find total number of distinct students who have taken course section taught by instructor with ID 10101. So let's do this one subquery. This one way. By the way, you can do this one in a simple way, but here just the purpose of this query to illustrate how can we use a set membership that tests the membership with more than one attribute relation. So here, let's take a look. Always check the subquery. Subquery is the simple thing. Gonna find out the list of the courses, okay, that teach by this instructor, right? So here, what I need the course ID, the section ID, the semester and year, because it's not enough to just give me the course ID, because I need to make sure that the course ID is one the student, when the student take register or taught, have taken course sections taught by instructor, I need to give me the information about this section. So in this case, you need the course ID, the section ID, the semester for the section, and year. That's the information that I'm looking for. So I extract this information, all the course that taught by a specific instructor. Here, this one we have what? Relation. That contains the course ID, and section ID, and semester and year. And this will be a result set that contains maybe data. Good. Now they'll be evaluated again. Execute the subquery first, then after that get the results of the subquery and pass to the outer query. So now here the system, when you execute this one, or the database management system doesn't see select whatever. It's gonna see something like this. The result gonna be here. So n, and then gonna be in this result set. Okay, good. Now starting for execute the outer query. So for every single, say first here 1 and 2, right? Then after that we perform select 3. So the first select for every single tuple of this relation, you need to make sure that this tuple is going to be part of the result must be what? The course ID for this tuple. The section ID semester year must be n. So it looks like I'm looking for the tuple that contains the course ID, the section ID, semester or year for a specific value here. Whether it's going to be here or here or here. So match all the attributes for this for every single tuple and the result set in the subquery. If you found match, it's going to be part of the result. Okay? So if yes, that's me starting to do so. Evaluate this one, then after that, you're going to count before and say how many unique distinct ID you have here. Unique student ID. Clear? That's all about the set membership. So let's take a look. How can you do the set comparison here? So what exactly here? So here you can, it looks like you can perform the word class. I need to compare a value. I'm not going to say whether this is a membership or not. Decide whether it's going to be a part of the subset or not, or the result set or not. No, here I'm going to compare this one. Once you can, the same thing, you're going to go to the execute the subquery. then gets the results subquery, then pass to the outer query, and in the outer query you're going to start to execute that, and now we're going to say what? Something is greater than whatever the result set that we have here, or less than, or not equal, or equal. Okay, this kind of comparison that we're going to perform here. So we're going to compare, in this case, generally speaking, when we say something greater than something else, compare, let's say, scalar value, okay, that's unique value, that attribute has only single value, with what? With the set of values it's going to be returned by the subquery. I'm keeping pointing here, while that I meant this part, okay? So let's have an example here. We say, yeah, by the way, how to compare? What does it mean to compare the value? Of course, we need to either the value is greater than, smaller than, not equal, and etc. Yeah, the sum value of the result set that can be used by the subquery. Assume that you want to have the names of the instructors with their salary, or the salary, or the name of instructor, where their salary is greater than of some at least one instructor in the biology department. We did this one before. So in this case, what we did, that's what we have done before. So we said select distinct the name of the instructor, where, so it looks like we're going to X the relation instructor twice. So that's why we're going to use an alias, okay? T and this. So it looks like T is going to be one copy of the instructor, and this another copy of the instructor, okay? So in this case, I'm going to say this, every single tuple, first of all, you need to perform what? Here we say, comma, I do Cartesian product. So this every single tuple of the T is going to be concatenated with every single tuple of S. In order to make sure that, do you need to have like filter out based on the instructor ID? There is no need in this case, because what I'm looking for here, I'm looking for just the salary of the instructor of the T here. It's going to be greater than the salary of the instructor in the S. And here's, I've said what? S is going to filter out all the tuple that satisfy this condition. So here, it looks like in the instructor S, or the S, or result set, or the attribute or relation, relations, not attributes, it's going to contain all the list of the instructor that belongs in the biology department. That's what we did here, all right? And here, for every single other instructor, or tuple that belongs to this instructor, I need to make sure that this one can be part of the result if the salary of this instructor is greater than the salary of any instructor in the biology department. That's what we have done before. So now we're going to do this one different. I'm going to use this one using, for example, greater than. So it looks like I'm looking for something. This salary of the instructor is going to be greater than some of the instructors of the biology department. I didn't say all of them. You say that with the salary greater than of some, at least one instructor. In order to perform this one, use a subquery. So I'm going to formulate my set comparison as follows. I'm going to say we have an expression, which in this case is going to be whatever the salary, okay? It's going to be what? Like operator, and it is sum, and we have a set here. So here we can say salary, operator can be greater than, less than, not equal, equal, sum, so it depends whatever you try to achieve here, okay? Since you said it's greater than sum, so in this case I need to have the salary is greater than sum, less of, let's say, result set gets value computed by the subquery. Whereas in this case, I'm gonna say, let me write this one again. I say the salary is greater than sum, the subset here, that the subquery which contains all the salary from, let's say, biology department. Okay? So that's what we're going to do right now. By the way, if you try to implement this one, use a SQL, Postgres, here we don't have some, they use any. Okay? Both of them are the same here. So now they have minor variation. What the database management system, the standard states, and the other what they're doing here. I think we can use both of them, but I guess any works. Anyway, so let's take a look here. Again, I'm focusing on the subquery. Subquery is going to produce what? Select the salary from the instructor with the department name equal biology. Here we're going to list, remember you need to compare something with a subset of the value that's computed by the subquery. Subquery is going to produce the list of all the salary here of the instructor of the biology department. So here the list of salaries is going to be here. Then now I need to execute this one, pass the result, or get the result and pass to the outer query. Then after that, now execute the outer query. The outer query starts one tuple at a time for every single instructor. It's going to be part of the result if the salary of this instructor is greater than some of these values here. Can you give me the result I'm looking for? Yes, because they said names of instructor with the salary greater than one let's say of some or at least one instructor in the biology department. So this one gonna give me the result that I'm looking for. And again, you can use listen, greater than, equal, greater than, equal, not equal, equal some, and etc. Clear? Okay. So this is the definition. Just to give you an example, to assume that we have the salary, whatever the value, is less than some, and this is list here, it can be computed, or the value to be the set of values returned by the subquery. So when you perform this one, F5, you can compare where, for example, 5 less than some. So 5 less than, let's do this one as a subquery here. Okay, with the 5 less than some, and if I'm going to say of the set of values, with this set of values or not. I need to compare this one. Yes, 5 less than some, at least one of them. So it's going to be true here. 5, where 5 less than some, this attribute here, false. 5 not less than 0, 5 not less than 5. If I found any of them, at least one, then it's going to be true, otherwise it's going to be false. Is 5 equal some? Yes, true. 5 not equal some, yes, in this case true. And here we can say equal sum is going to be equivalent to the n. So either going to be equal to sum, you can say 5, or they say salary equal whatever the sum, or you can say the salary, or they say, I should do the x is better, x equal to sum, subquery, or this one equivalent, you can say x is n, and you use the same subquery, it's going to produce the same set of values here, which makes sense. N must be at least one satisfy this condition. I'm talking about the equal sum. But whether not equal to sum, whether it's going to equivalent to not n, no, it's not the same. Because not n is not enough, because not equal to sum. Why, by the way, why not equal to sum, not equivalent to the not n? What's the not n going to do here? Give me, for example, the value of x, not in this case. Not exists in the subset here. Here I'm talking about not equal to sum. I'm looking for the equality here. Okay? How about the all cause? Can you use this one? The same thing here. Either going to use a sum or any, as you mentioned, or you can use all. What does that mean, all? Now I need all of them must satisfy this condition that I'm looking for. Okay? The same query, but I need to modify this one. Names of the instructor, whose salary is greater than, let's say, greater than the salary of what? All instructor in the biology department. So that means in this case, you need to have subquery produce to come up with, say, the list of the salary of the old instructor in the biology department. Then in this case, I need to make sure the salary from the instructor, the outer loop, must do what? This salary must be greater than all the salary that for every single instructor of the, let's say, in the biology department. Make sense? There is another way. You can compute the maximum one and say it's greater than the maximum. You can do this one. So you have a different ways, okay? So make sense this comment, this query? And this is here just to give you a definition here. For example, 5 less than all, this means must be less than all. Less than all, yes, true, all. 5 equal all, false, because it's not equal all here. 5 not equal all, true, because at least you find someone is not equal. I mean, all of them, sorry, not at least one. All of them must satisfy this condition. So not equal all is equivalent to what? Not n. Exactly. That means it's not there. Not equal all of them here. But here, equal to all, that means not equivalent to the n. Because equal to all, you have to make this, for example, 5 in this case is going to be equal to all. So it's going to be false. If I said n, 5n, let's say, if you use n here. 5 and n, yes, it's going to be true here. So that's why we said this is not equivalent in this case. So far, so good, hopefully. Okay. So, do you have a way in order to test whether, the subquery has any tuples in its result set or not? I can build the subquery, and I need to figure out whether the subquery has a result, any result, or any tuple or not, or empty, something like this. The SQL have a feature which allow us in order to perform that. So in order to test for the empty relation here, I can use exists, okay, or not exist. So in this case, by the way to use this one, I'm going to say, for example, where here, okay, I'm not going to compare something with something else. No, I'm going to say where, I'm going to say exist. And here we have subquery. It's not something like a salary is a n or greater than some subquery. No, that's different. Here, this is the way how to use this one. Okay, where exists subquery. So this one is going to be, in this case, it's going to be either evaluate to the true or false. Based on what? Based on the content of the subquery. If you said exists, okay? So if the subquery, okay, return the value or has any tuples, it's not empty, it's not null. There's something. I don't care about what the list of, the set of attributes is going to be returned here, because I'm not going to use them. The only thing I'm looking for here, you can say select a star or whatever. I don't care. But the most important thing here, I need to see whether the subquery is going to produce a result or not. Any tuple, 1, 2, or more. If we do this one, so in this case, this one is going to be evaluated to the true. If the subquery is going to have a non-value, produce nothing, is empty, there is no result, there is no condition where select star from whatever, where this condition, there is no tuple satisfy this condition. So this one is going to be evaluated to the false. So that means whatever tuple I'm working in the outer loop, this is going to be part of the result or not. It depends in the evaluation of the existence, whether it's going to be true or false. So exists, so where this one is going to be part of the result, or at least we have something that can be part of in the subquery. So yes, it's going to be true. Otherwise, it's going to be false. Not exist is different here. So the same thing is going to accept only argument as the subquery, but here's different. That means not exist, it's going to be evaluated the true if the subquery is going to be empty. No, produce nothing. There is no result. Okay? So this is the difference here between of them. Let's have an example. So for example, this is another way, by the way, different ways, just for illustration here. I'm going to talk about the confusing part of today's lecture is called correlated subquery. Okay? It looks like in the nested loop, you have for I equal whatever, and after that for j equals something. Then after that, within the loop j, we're going to use the value of I. That's what's called correlated subquery here. We're going to talk about this one. Let's see first. So, find all the courses taught in both 2017, in the fall, and the spring 2018. I need it here and here. So this code must intersect. We do this one with the intersection, right? Now let's see this one using a subquery, different way, see how it works. So in this case, I'm going to say, let's take a look at the subquery here. You said select star, whatever. I don't care about, when you use exist, I don't care about the content of the subquery. What's going to be, how many columns? All of them, some of them. The goal of when you use exist, I want just to test whether the subquery has a value return at least one tuple or not. If you return at least one tuple, the exist is going to be evaluated to the true. Otherwise, it's going to be evaluated to the false. So take a look here. Let's take a look at the structure, how it looks like. Then after that, see what's the relation between them. Select, start from the section, where the semester equals spring and here 2018. So it looks like I'm looking for the spring 2018. Course offered in this time, right? Good. What else? Oh, total that time. Sorry, because I'm talking about the section here. Okay, offered by. I'll talk about. I mean, offered. Yeah, offered the time. Total is okay. Both of the same. Good. What I've said here, and the course ID for the S. So it looks like I'm accessing this section here. Sorry, the T course ID from the one that I use in the inner loop is like correlated to what? The S.course ID. What's the S course ID? Something that relates to the outer loop. Have a pointer somehow. So if you take a look at the outer loop, that you're gonna say this course ID is gonna be part of the result from the section. I call this one an alias. Okay, where this course is gonna be offered in the fall and year 2017. And this course and exists, and this one is gonna be evaluated to the true. For this course, gonna be part of the result. I use this one inside this one in order to perform the equality. To looking for this course in the inner loop. So in the inner loop, find all the course over 2017, and at the same time, the course ID for this course that satisfies this condition must be equal to the course ID that offered or that satisfied the condition in the fall 2017. We call this one, the variable is as a correlation name in the outer query. And the subquery in this case that have a correlation name is called like what? We use an attribute that belongs, at least one attribute that belongs in the outer query. We call this one correlated subquery. Okay? Let me go over this one more details. Generally speaking, let me go. I think in this case it's better to have go to the whiteboard here. In the SQL database, generally speaking, query, a correlated subquery is what? Is a subquery that's correlated. Okay, I don't know what happened. Is a subquery. Okay, good. That's what. So we talk about the query inside the query. We did this one that uses values from what? From the outer query. That uses values. Let's say value of values. Okay, from the outer query. So you see the select star, whatever the value course ID from the section S, where let's say fall 2017 and exist. And the subquery select a star from the section T, where the course is going to be offered to say this spring 2018, and the course S.course ID that belongs to the outer loop is equal the course.id that belongs to the tuple that satisfies the condition of spring 2018 and must be satisfied the outer code. Yeah. So how can you evaluate this one? So the subquery is going to be evaluated once for each row processed by or tuple by the outer query. Okay. So for every single outer query, you're going to perform the following. First, you're going to get what? This is like order of execution. You are going to candidate tuple from the outer query. So this is different a little bit. How can we execute subquery? Is a correlated subquery. If subquery, we talk about this one, how to perform this one. First, you need to execute subquery. Then after that, gets the results of the subquery, pass to the outer query. Then after that, you execute the outer query. Here's different a little bit. Why? Because we do have correlated subquery. We understand what do you mean the correlated subquery. Okay, so that means the inner query is a subquery, which is gonna be what? That use values, maybe one or more, that or from the outer query. So somehow we have some attributes that belongs to outer query can be used within inside this subquery. So the order or the way that evaluate in this case is going to be different than the way that evaluate the subquery, because it's a here correlated subquery. So we're going to do this one as the following. First, you have to do get. What do you mean the get? You're going to get the candidate tuple from the outer query. So the outer query is going to say, for example, I'm going to assume that this course ID is going to be part of the result from the section where the as they say S, I guess, yeah, use S from the outer. So this tuple, or they say T1, belongs to the relation S. Okay, with the section, but I'm going to use it's going to be part of the result. This is the candidate tuple that satisfies, for example, fall 2017. Okay, and So let's say fall 2017. And now once I get that candidate tuple from the outer query, now we're gonna execute. So the second step, we're gonna perform execute, okay? So in this case, I'm gonna do the inner loop using the candidate tuple value. Inner query, sorry. It's confused because nested loop, inner loop, and etc. Anyway, inner query using candidate tuple value. So what does that mean here? Remember we said where the course ID from the outer loop is equal to the course ID from the inner loop. So that's what it get the candidate tuple from the outer query and execute the inner query using this candidate tuple value. It depends on the value that we have based on the T1 that belongs S. So here I'm going to perform for every single, let's say R that belongs every R that for every single tuple R that belongs to the relation T, where there's going to be another copy of the section, needs to going to perform what? I'm going to check, for example, the T1 dot to say course ID with whether it's going to be equal to say R dot course ID or not. If yes, that means this is going to be part of the result. Of course, we have another condition. This one must be spring 2018. Yeah, that's what it is. Then after that, we're going to use or whatever the values that from inner query in order to quality or the qualify or disqualify the candidate tool. Then after that, after you perform execute this one, now we can specify whether the candidate tuple that I'm going to choose from the outer loop or the outer query, whether it's going to be part of the result or not. So I'm going to use, in this case, the values. Remember, we're going to be exist. Now we're going to execute the subquery, and based on the value that we have, whether it's going to tell me whether it's going to be, for example, the outer query, it's going to be, or the tuple from the outer query, or the candidate tuple from the outer query, it's going to be qualified as a part of the result or disqualified. You say to qualify or disqualify the candidate tuple. Okay? Hopefully you can read my hand. Yeah, I guess. So back to the slide and go over this one again and see how can you perform this one. I will go over this one again. Okay, we are here, yeah? So again, so in this case, I'm gonna, how can you evaluate this one? First, I'm gonna check the course ID from the section. So I ask for every single tuple of the section here, you need to make sure this tuple, the one that satisfies this condition, fall 2017, okay? This is a candidate tuple. So we have, for example, T1 and T2 and T3. We have 3 tuples that satisfy this condition. Assume that. For each of them, going to be candidate tuple. Still, I need to check and evaluate the subquery. And the subquery is going to help me whether this tuple is going to be part of the result or going to be excluded. For every single tuple here, with a candidate tuple from the outer query, now I'm going to execute the inner query. So inner query is going to do what here? Select a star from the section T, where the semester spring 2018. So assume that we have, for example, let's do this one different. S1, S2, S3, just to use the symbol, the same symbol here. And here we assume that T1 and T2, T3, T4. All of them satisfy the condition that spring 2018. And now we need to use that for each single tuple. Now, right now in the first tuple, candidate tuple from the outer loop, I need to get the value of the course ID here equal to what here? Whatever the value of course ID. I'm going to use it here, and here compare with the T course ID that satisfies this condition. If this evaluates this one, depends whatever value you're going to compute here, with the equality operator or etc. If they're going to be equal, then in this case, you're going to perform this one for every single tuple here. Okay, so for every single tuple, the outer loop, we're gonna perform this one, evaluate this one with every single tuple in the inner loop until to figure out whether they're gonna be find the result or not. Once they done that, what's gonna end up here? We're gonna have something. Either we're gonna have a null, empty, or maybe you're gonna have, let's say, one or more tuple that satisfy this condition. Remember, it exists. That means this one is gonna be evaluated. This tuple is gonna be part of the result if this one satisfies this condition. Plus, when you perform the subquery, this exists. When you perform the subquery, that means this cross ID is almost, or also, sorry, as offered in the spring 2018. So this one is going to be qualified, this tuple is going to be part of the result. If not, it's not going to be part of the result. Now, go to the next tuple and perform the same operation over and over. So this one in a loop is going to perform this operation over and over. Make sense? Is it clear? Okay. And this is how to summarize what we have said here. I know it's a few points. Maybe you need to add more slides to give more details that they cover how to perform execute. How can you first get the candidate tuple from the outer query, how to execute a query using the candidate tuple value. Then after that, use this one to get the result, get the inner query result in order to whether qualify or disqualify, say the candidate tuple. Whether it's going to be from the outer query, whether it's going to be part of the result or not. Generally speaking, the correct subquery, try to avoid them unless this is the only one in order to execute the query because they are so too slow. And you see, for every single tuple for the outer query, which satisfy the conditions that we have in the outer query, well, you need to evaluate against every single tuple in the let's say in the inner query. So it looks like, for example, n multiply n times in order to perform this query. Yeah, n number of tuples of the relation outer query, and n is going to be number of tuples in the subquery that we need to ask them. We have something else. What you're going to use not exist, which is similar to the exist, but it depends here. And here, I believe it's better to take a rest, okay? Because I want from you to be awake when you talk about the not exist, okay? So let's back into 36, okay? Take a rest, cup of tea, then shake your head in order to get back in order to talk about the not exist clause, because it's very important here, okay? See you in 15 minutes. Okay, we're back. So let's take a look how can we use not exists, okay, clause. So assume that to give you the square, and they ask you to compute to say, or find to say, all the students who have taken all the courses, okay, you see, offered in the biology department. So in order to answer this one, this is, I guess, I'm not going to say the only way, but we cannot answer this one without, let's say, corrected subquery, okay? Of course, we can use this one as the view. There's a different story, but based whatever we have, this is the only option that allows us to know the answers the query. Actually, we can make it complicated, yeah, using accept, etc. Yeah, I believe we can do this one, different story. Anyway, so in order to find out the students who have taken all the courses offered in the biology department, this is my answer. So I'm gonna say select the student ID, student name, because they need to say, for example, information about the student. Maybe you don't need the name, it depends on you, okay? From the student where not exists. So this one, this means must, what does it mean not exists? That means this one must be evaluated or must be produced to say non-value. In order this student, or the each candidate student, or the each candidate tuple from the student relation to be part of the result, right? So let's take a look here. What do you have here? First, you're going to do what? So not exist, and within not exist, subquery, and the subquery is going to contain the subquery. I mean, except. When you perform the except, the speech in this case, or the set relation, okay? Set relation, that speech or operation in this case. So we're going to perform what? We have like one query, this part, except this part. So let's take a look at the first one. This one produces what? A list of the courses offered in the biology department. List of all, let's say all courses, let's say course IDs that offered in the biology department. Okay? Here, it's gonna do what? It's got a list of all the courses, okay, taken by specific student. Okay? So this is called a subquery, and the way that you say evaluate this one, I need to find the candidate, get the candidate tuple from the outer query. So assume that in the student we have student 1, student 2, student 3, only 3 tuple, for example, just to simplify the process. For each of them, it's gonna be candidate query or candidate tuple, right? I need to evaluate this one using the inside the inner query. So when you execute the inner query, I'm going to use the candidate query tuple or the candidate tuple value within the subquery. So here, assume that we have a student ID, for example, 1 and 2 or 3, okay, for this example. For the first tuple, the student ID is equal 1. Okay, I'm going to do what? Not exist. This one going to be part of the result if this one evaluates to the false. What evaluates the false? This part is going to always compute the list of course over in the biology department. So it's going to be course ID, for example, say bio 1, bio 2, for example, bio, say, 100. Just for simplicity, okay? Then this part is going to execute what? Find all the courses taken by this student. Whose student? The student that I get information from the candidate key, or the candidate tuple here, from the outer loop. So in this case, find the list of the course ID from takes give me the list of courses taken by every single student, okay, where the student ID in this table, with this relation, with this tuple, must equal to what? To the student ID from the outer tuple, or from the outer relation, or from the outer query, actually. For every single tuple here, for example, student ID, I need to find out the list of the course taken by this student here. Then, assume this course or this student, for example, is going to have the course IDs, some of them in biology, some of them math, some in computer science, whatever, list of course all taken by this student. I'm going to say student ID, for example, 1. Okay? So in this case, I'm going to perform the list of the courses offered by the biology department, except here, the list of the course taken by this student. I do have two possible results. Yeah? The first one, this result will be performed except we have a null or empty, or they have some courses are left, or some tuple. Alright? Let's take a look at the first scenario. What does it mean if we perform the list of all courses by the biology department and remove, we say, subtract this list from the list of all courses taken by this specific student or particular student, and the result can be empty? What does that mean here? That means this student takes all the courses offered by the biology department. So this one can be evaluated not exist, this one can be empty, so this tuple or this student is going to be part of the result. If we try to say subtract the list of the courses offered by the biology department from the list of all courses taken by this student or particular student, and we figure out there's some courses are left. What does that mean here? That means this particular student didn't take every single course offered by the biology department. And why? Because you have, for example, maybe bio 1 or bio 2 is going to be left over. So in this case, the not exist here. You're going to evaluate the subquery, and the subquery is going to have what? Some tuples. As long as this tuple is going to have, or this subquery contains subtuples, this means in this case, we end up, or conclude here, that this student didn't take every single course that's offered by the biology department. Then in this case, this student is not going to be part of the result, or this tuple is not going to be part of the result. Okay? So, again, the first nested query lists all the courses over the biology department, this one, and the second one again just to find out all the courses that taken by particular students. And here you see, for example, this is x, assuming this is y. If you said x minus y is equal empty, that means x subset of y, right? That we know. If you try to use this one using equal all, is not gonna be, we cannot do this one. this is the easiest way how to do this one using answer this kind of query. Okay, hopefully it makes sense to you guys. Okay, sometimes you try to what? You need to figure out a test for absence of duplicate tuples. Something like this. We're gonna see, for example, with a subquery, all depends on the subquery right now. Okay, if this subquery or query is gonna have whether it's gonna have duplicate tuple or not. Okay, so we can use unique. By the way, this is the standard. It's not you cannot use this one in the SQL. In Postgres, for example, because you're gonna say we don't implement this one. This one kind of unique, or say this functionality of this feature is not implemented yet. Okay, so this is unique construct with test whether the subquery has any duplicate tuple in the result or not. So this one is going to be evaluated to the true if the given subquery is going to contain, let's say, no duplicate. So it looks like the same way that we did with the exists. Okay, so in this case, you're gonna the way that to perform this one, the unique, and take an argument as a subquery, and this one is going to be evaluated to the true or false. True, that means every single tuple here, it's unique. It's unique. There's no duplicate tuples have the same value. Or in other words, you don't have more than one tuple that have the same value. Okay? Or repeat it. False, that means if you find at least one tuple has, there's a duplicate in the result set. And it depends what you plan to do. What we have kind of information going to be stored here. It depends what you're going to project, what's going to have in the tuple here. Maybe you have one tuple attributes, more than one attributes, it depends. Okay, so let's try to use this one. If I ask you this question, find all the courses that were offered at most once in 2017. What does it mean once? Actually, it could be 0, 1. That's the meaning. At most one is 0, or it might be once, okay, in the 2017. So the way that to answer this one, I'm going to use this one using unique, okay? And unique in this case, this course, again, this is subquery, this is the way how it works. You're going to compute or come up with a get the candidate tuple from the outer query. Here it's going to be about this, I guess this one is going to be part of the result, F. And you need to check this one. Within the subquery or created subquery here, it's going to tell me whether this tuple is going to be qualified, going to be part of the result or not. Yeah? So in this case here, I said unique, where unique. So select the course ID from the section, which is going to be all the courses that offer in this section, okay? Where the course ID is equal course, so that means this course that gives me the outer loop is going to be part of the result. If this course I found that exists, there is a tuple, for this tuple is going to be in this section here. Okay? What if we have found out this course ID is offered many times in the 2017? For example, the course ID either going to have, for example, CS425, for example, maybe 2 or 3 times. I'm not going to use distinct here because I need to make sure whether it's offered more than one time or not. You can use the count, by the way, but here this is the way how can you use unique. So this one is going to be evaluated here, and for every single tuple from the outside, from the outer loop, if we found this, there is a duplicate value from the course ID that I received here, okay? So in this case, within the outer loop, the value that we have here, so in this case, this is not going to be part of the result. So I said CS425, it's not because we found this one offered multiple times here. Okay? The problem with the unique, it's like, it's not implemented in most of the cases here, okay? So how can you perform that? And also it's gonna return, would be evaluated to the true on the empty set. So if we have an empty set, the subquery is gonna evaluate to the true. So maybe we don't have this one. It depends on the application, or this depends on the query that we're looking for. In our case here is fine because empty is gonna be true. The 0 or 1 is a fine. But sometimes it depends on the query that you try to execute or try to perform. Maybe it's not a good idea. Again, in both cases, since it's not implemented, I need to figure out a way how can you use this one. So if I'm looking for the course that I offered more than at least or at most once, what I'm going to do here, I'm going to say where 1 is greater than or equal and subquery. And in subquery, I'm going to count the number of times the course offered. Okay? Of course, with every single tuple, it's subquery, related subquery. So here, for every single tuple of the, let's say, the outer query. I want to consider this tuple going to be candidate. Then after that, execute the subquery and see or create a subquery and using the value for the candidate tuple inside the subquery. Then after that, after execute the subquery, you need to figure out to find out a way whether you're going to say this candidate say tuple from the outer query is going to be part of the result or not. It looks like I'm repeating myself. I'm trying to emphasize that to make sure that we are on the same page. The same mechanism, but the different, we are trying to apply this one in different places in order to make sure that we understand what's going on here. The same structure, the same mechanism, okay? So here, assume that we have CS, let's see, CS425. I will take this list of the courses from the relation course, which contains, the list of the courses in the university. CS425, CS525, and the rest of the course. For each of them, it's going to be candidate here. It's going to be part of the result, hopefully, F. 1 is greater than. So here I count how many times I found this course is going to be in the section relation. And the section is going to contain all the lists of the courses that offered, okay? In the university. So it's going to be the rest of the section here. I don't care about the section. I'm care about one thing here. I'm care about here whether this course is going to be offered in 2017 or not. That I'm going to do. So I'm going to count the course ID in this case. Here it might be 0 or 1 or 2 or more. So I'm going to say what? I need to have what? At most once. So I'm going to say where the value of 1 is greater than or equal the value here. So that means if the 1 is greater than or equal 0 or 1 is greater than or equal 1, that means at most 1. So if the value of 2, this is going to be, this one is going to be evaluated to the true, this one is going to be 2 or 3, and etc. is going to be evaluated to the false in this case. You see that? So you can use this one in order to tell whether it's going to be at most 1 or at most 2. So if I ask a question, if I wanted to have the query that find all the list of the course, for example, to say, were offered at most, to say, twice in 2017. If it said twice, the only thing you have before what? At most twice, that means 0, 1, or 2. So in this case, you only do say 2 is greater than or equal, and the same query here. What if I change this one and said at least twice, or 2 times? Let's say this one, at least. At least 2 times, this means you need to compute the count, and the count you have 2, 3, 4, and etc. So in this case, you're going to perform what? You're going to say where, or let's do this one here, where 2 is less than or equal, whatever the result here. So this is going to give me at least 2 times, okay? Because 2, 3, less than or equal this value. Can I do this one? Yeah? So the smallest value 2 and above. Okay. Do you have any questions, guys? Is it clear so far? Okay. So if I ask you the question here, find all the processes that were offered at least twice in the 2017. I'm going to try to use this one not unique. Okay, you can use the same thing with unique or not unique, or you can use what I show you here at least 2 times. That means you can use 2 less than or equal, and here you have to select count the same that one that did the previous slide. Good. Now I'm going to show you the query or subquery that we can use in the form. Right now, what all the subquery that I show you, that we use this one in the where class, right? Now we're going to see how can I use this one in the from class. Okay, so if you take a look at the form here. So, for example, if I ask you this query, find the average instructor salaries if those departments where the average salary is greater than 42,000. I remember we did this one today class. We use this one using having, right? After I compute the aggregate function, then we make sure that having the average salary is greater than, let's say, this value. That's what we did here. There is another way in order to do that. So what I'm going to do here, I'm going to use a subquery here. So it's a subquery in the from. Remember, the subquery always produces a relation. Okay, there's a number of tuple, number of columns. This is the result set. So you can use them here. So first, I'm going to take a look at the subquery here. What's the result here? This subquery is going to create, let's say, a relation that contains the department name, 2 columns, name, department name, and the average salary. Okay? Which contains information CS, math, and numbers, etc. Right? This is, the outcome of the subquery. So now it's not called a subquery. First, execute the subquery. Then after that, pass the result to the query, or the outer query. Now execute the outer query. So now the outer query is going to say, now start with the from. When you start the from, what do you have? It looks like we have a relation, right? That contains the department name and the salary. Okay? Then, now, someone going to say, from, after execute this one, this outer query start with the from, access this relation, true can perform where average salary greater than this value. Yes, someone is going to say, can you use the column name or alias that you use in the subquery? Yes, because after the order evaluation of the execution, you have to start first with the subquery. Execute this one. So in the subquery, now we have department name and we have the average underscore salary. You can use both of them as the name of attributes. Then I said where the average salary is greater than this value, so you filter out all the tuple that satisfy this condition. Then after that, now number 3, you're going to perform select the department name and the average salary, so you're going to give me the same result that we get before. Clear? When you try to write this one using Postgres, okay, or MySQL here, if you do this one, you're going to say, it give you an error. And the reason behind this one, they said, you have to specify the name of the relation of the subquery. You're going to see this one. If you use a subquery, the Postgres, on MySQL, I guess to do the same thing. When you execute this one and try to, maybe you're going to try, we'll try to test this one today. I'm going to go over, let's say, short tutorial, how can you use the Postgres, how can you try to start doing, let's say, some queries here, okay? So you can test this one in your own time after the class. So in this case, in the Postgres, required from you to have like the name, you have to give the name and alias for the subquery. So if you didn't do this one, the Postgres is going to give you an error message. So just to say, for example, you can say as, for example, R. And you can specify the name of attributes as that we did. As, we call this one, it looks like called the name, department, they say relation, which is going to contain, let's say, like a temporary relation. It's called department underscore average. And it's this temporary relation is going to contain 2 columns with the department name and the average salary. The first one is going to take whatever they have, the project, the first one. And the second one for the average salary, you're going to rename this one into this one as the alias or the name of the attributes in this temporary relation, which contains information about every single department associated with the average salary per department. Then, now, once you get this one, we can use this one as, say, you can say, for example, average salary, or we can say, for example, whatever. You can say department name or department average dot with the name of the relation as the average salary. You didn't need to perform this one because the average salary is unique here. Average underscore salary is unique because this one belongs to the subquery. But again, when you try to execute this one using Postgres, they're going to require from you to have like an alias, okay? Especially for the from class. Okay? You must give it a name. Even the name of never reference, if you are not going to use this one, but this is the structure for the Postgres and the MySQL. You have to do something like this. Okay? With the class. So, I'm going to show you that the way sometimes you can create, it's not temporary relation, it's kind of temporary relation, which allow you in order to simplify the query that we have. Complex query, maybe you can create to say relation 1 that contains set of attributes, we'll say subset or we'll say result set. Then you can compute another relation, another relation, another relation. We call this one sometimes like a temporary relation. It's not accurate 100%. Okay? So anyway, I'm going to talk about what is called the common table expression, which is called a temporary result set, or defined as a temporary result set, okay, which we can reference within another SQL statement. You can, when you say reference another SQL statement, you can use this one in the select, you can use this one in the insert, you can use this one in the update and etc. Okay? So what's the common table expression? Sometimes we can also common table expression. I'm gonna get back to this one later when you talk about how can you create a view in the intermediate SQL part. So anyway, this is the common, let's write this one in the name, common table expression, which again is defined as a temporary result set, which can be referenced using any other, let's say, SQL. So what does that mean here? This looks like a temporary, okay, table we can use right now for this query, only for one query, okay? So that means if you try to use this one later here, the system is going to say, I don't know about this one. That's why we call this one temporary, okay? So again, it's only exists, and the reason behind this one is because it's only exists during the execution of the query. And the structure, when you build this one, this is the syntax in order to create what is called the common table expression. You can use with, okay? We call this one sometimes with the class, okay? And you have to give me the common table expression name, whatever the name, or the table name, whatever table or whatever. Then after that, you can specify the column list, okay? You can inside the after you perform, let's say, specify the name of the common table expression, you can following it by an optional, yeah, funny option, I don't know, by the optional, let's say, column list, okay? So it means you can say what the list is going to be stored in this relationship. Then you're going to say as between two parentheses here, you can say select from where. You can give me like a SQL query in order to generate or create this subset. So it looks like instead we have the subquery. I'm going to take the subquery and put it in the with the class to create like temporary result set. I can give this temporary result set the name and the list of optional, let's say, column list, okay? Then after that, after we define whatever the common table expression here, I can use this one right now. I can use during the execution of the query. Then after that, I'm going to specify the query that allow me to access this one as a temporary relation. Let's have an example here. Assume that I want from you to find all the department with the maximum budget. This is one way. So you can simply, if you want to go with the common expression or table expression as a temporary relation, let's do this one. It's actually the temporary result set, but it's okay. So I'm going to say, well, what's the name? I need to create a relation or temporary relation or result set. What's the name of the temporary result set? Assume whatever name we have. I'm going to say maximum budget. And here you can specify the value with a list of, let's say, an attribute. Okay, it's going to be option. Here, when I say option, that means if you wanted to use the same, let's do this one. You select maximum budget from the department. Reduce what? Then after that, I'm going to go to back to the column list. This one, I'm going to create a relation, okay, that contains one attribute, one column. It's called, let's say, I don't know what's the name, it's going to be here, and contains the maximum budget. So we have only one value, for example, 90,000, something like this, okay? This is what the outcome of this part. Now we want to store this one into any relation. I'm going to call the relation maximum budget, so it's going to be max budget. And I need to rename the attribute. It has a specific name. So that's why I need to specify the name of attribute here. Assume it's going to be value. So this one is going to be value, and the value is going to have the maximum budget. Okay? So I create a relation that contains the highest or the maximum budget among all the departments. They ask me to find all the departments with the maximum budget. Once you create this one, now I can use it now with the SQL. Here, direct. I cannot use this one later, only for the next or the same SQL query that we have. Or let's say, can be only executed, exists, let's say, during the execution of the query. Because this is one query, by the way. The first one you have a with, create a let's say, temporary relationship, then after that you can use it in the query. So here I'm going to say select department name, because list of the department with the maximum budget from the department and the maximum budget, where the budget equal the value. What does that mean? You remember, in the department relation, we do have a budget. And you need only the list of the department, their budget is equal to what? Equal to the maximum budget. what's the maximum budget? I divide this one or the value of the maximum budget, because in this relation or the temporary relation that contains only the maximum budget. I can do this one in different ways. The one way here, or the other way you can see with, let's say, maximum budget. I'm not gonna specify any, let's say, that column here. I'm gonna say as, and here I'm gonna say select. Let's say max, let's say budget. You can say as what's your value, the same from department. Okay. Then after that you can use the same query. Clear. So it looks like make our life easy. You can define many, let's say, temporary result set. I would say this is assume that many, let's say, temporary relationship or the tables, and we can use them within in the same query here. This is, by the way, this is a part of the query here. So the first one, define the common table expression. Then after that, use this one in order to help me to evaluate the query. Make sense? Hopefully. So let's see another example which allow me to define more than one common table expression within the same word cloud. It's fine. You can do that. Okay. For example, ask me find all the departments where the total salary is greater than the average of the total salary of department. Where the total salary is greater than the average of the total salary of the department. Just as this one is following. I'm gonna make it simple. Okay, by the way, you can use subquery, you can whatever, but this example just that help us to understand how can you make the complex query using the with the class. I'm gonna say well. The first one, by the way, when you try to use the name, try to use the same name that makes sense. It's easy to understand what's this view of this common table expression, or what's the result or temporary result set it's gonna represent, it's gonna contain. So here it's gonna be the department name and the value. Okay, it's fine. As okay, select the department name and the salary of each department from each instructor. Oh, sorry, from the instructor relation. So group by the department name. What I did here, I just compute the salary per department. Yeah, for every single instructor. For example, for the computer science here, there's gonna be the sum of the salary. For example, $1 million or whatever. Okay, I'm a lazy guy. Or from the math, for example, this guy is poor. It's gonna be 500, or let's say 5 to the power 5, something like this. Okay, and that's what we're gonna have here. And here we have some salary. So either gonna say as, for example, value, and you move this one, or you can use the same thing in order to specify the name of the whatever. Give the name for the attribute that's gonna be from the aggregate function. If you wanted to define more than, let's say, view or the comment, let's say, table expression, you can use only one with, okay? Then I'm gonna say comma. If you said comma, the system is gonna say, okay, it looks like now you define the first one, temporary table. Now we're gonna define another temporary, let's say, result set. So here I'm gonna say, now I'm gonna compute the department total average. I need just to make my life easier. This one I'm gonna compute the average of the department, or the average salary of all the department, for all the instructors of all the departments. So in this case, this one nice way in order to show you that if you define, let's say, temporary result set, you can use this one in order to define another temporary result set, okay? So in this case, I'm gonna say what? I'm gonna go to the department total, which I just generated, but it's gonna be available, which contains the department name and value, and the value actually is gonna be the sum of the salary, okay? That's what we compute here. So this is the first one. Then here, I'm gonna say department total average. It's gonna have the value, okay? It's gonna be only one attribute called value. Then it's gonna be select the average value from the department total. So take access to the value of the average here for what? For the value stored in this relation or this temporary result set, and compute the average salary or the average value for the whole thing. So result here, this one is gonna be at the department to say total average. Gonna contains what? One value. It's called one attribute called value, and have what? the average of the total salary of all the departments. This is the average of all total salary of all the departments. I put it here. Then now I'm done from the with the class. Now let's take a look. How can I need to execute this query. I can use whatever relation that you compute in order to produce a result I'm looking for. I need to find what? The department where the total salary is greater than the average of the total salary of all the department. So select department name from the department total and the department total average. Why I need to use both of them? Because the department name of this table, or let's say this relation, or this result set contains the list of all the departments associated with their average salary. Make my life easier. And here the department total average is going to contain the average of the total salary of all the departments. So I see here, what I've did here, I can say department underscore total with the value here, dot value, take the value that's stored here for every single tuple, and make sure it's going to be this one tuple is going to be part of the result, or this department name is going to be part of the result if this one satisfies this condition with the department total dot value here, with the value stored here. If that means the total salary of this department is greater than the average of the total salary of all the departments. Is it clear? It might be messy a little bit, but this is just show you that how can you use the view. You can generate or create a temporary result set. You can generate more than temporary result set in the same SQL query. Then after that, this one only going to be exist during the execution of this query. So later, if you have another SQL query, try to ask this department total, department to say total average, the system going to say, I don't know anything about these relations. There's something missing here. Clear? So we have something else here. We call this one, how can we use a subquery in the selected class? What does that mean here? In the select, you know that when you select, that means expect that this subquery is going to produce only a tuple that contains only one tuple or one value or single value. Okay? Otherwise, we do have an issue here. For example, list all the department along with their, the number of instructor each department. Again, maybe you're gonna have an easy way to execute that, but this is just a simple way to perform that. Okay? So the first thing is you take a look here, assume that, select, I'm gonna take the department name, and inside this one you're gonna see what? See what we have here. This is subquery. You're gonna select count from the instructor where the department equal instructor of the department name. Let me remind you with the order of the execution. The order of execution in this case is going to be first here. Then after that, now we're going to try to execute this one. Okay? So first, in this case, we have to ask the department. Yeah? Then after that, because this one in the select clause. Yeah? So in this case, you're going to count the total number of instructor per department for every single department. Yeah? Or for the department name, department name is equal instructor to the department name. Okay, so in this case, for every single department, it's going to produce what? The number of instructor. This is the way how can we perform that. So what the result is going to be expected? Do you expect to have more than one tuple? If that's the case, so this Postgres is going to give you an error. Say, no, you cannot, for example, here, because for the department name, I expect to have, for example, only one value. I didn't expect that we have maybe two different values. I'm going to choose one of them. No, the system is going to say there's a problem. So this is not scalar subquery. Scalar subquery, that be the query, or subquery that produce, say, a single value. Okay? And here we use this one, give a name for the subquery because this is the Postgres that it forced me to do that. Otherwise, I cannot execute this one. Okay. So again here, you access the department relation. For every single tuple here, you need to compute this one. And here with department, we do have the primary key is going to be the department name, right? So the value is going to be unique. We don't have a duplicate value for the department name. So again, for every single department that we have here, for example, computer science, now we're going to compute the subquery. We're going to compute the total number of instructors in the computer science. How can I perform this one? Where the department equal the instructor to the department name, and they get access to the relation, what? The instructor here, okay? Which contains the list of all the instructor for every in the university, okay? So here we can find out the way that how can be the number of instructor per department. The easy part. I wanted to perform some modification of the database. How can I do that? How can I do deletion? How can I perform insertion? How can I perform updating? That's the thing that we need to perform. I know we cover some of them in the beginning of this chapter, but here I'm going to go over more details. Deletion. In order to delete, this is the syntax of the deletion. This is how it looks like, something like this. We're going to have delete. Okay? And you have delete from. Give me the table name. And where you can have, let's say, condition or predicate. Okay? The where is going to be what? An option. So you don't need it. It depends. If you specify you wanted to delete all the tuples for this relation, then you can say delete from instructor. If you do this one, that means you're going to delete everything in this relation. Okay? Again, you use the predicate or the condition in the where clause just in order to specify which rows or tuple from the table to delete. For example, I wanted to delete all the instructor that works in the finance department. Okay? So in this case, you can say delete from the instructor where the department name is equal finance. So you can specify which tuple is going to be affected using this command. You're going to see this one later. When you perform this command or this operation, the system is going to give you like delete, then after that specify the number of tuples that has been affected. 1, 2, and 3. We're going to see this one in the Postgres when you try to execute this one. Okay? Another feature, we can see that in the Postgres. I'm going to try to do this one in the like a short tutorial. Either going to do this one today or maybe you're going to have some recording in order to save some time. Okay? So anyway, so you can use returning. When you perform this operation, you can say returning. And for example, you can specify star, or you can specify the list of the column that you wanted to specify. You're going to return. So in this case, when you delete, for example, assume that delete from whatever table where we have a condition here, and you say specify returning star. What does that mean here? If you said return a star or asterisk, in this case, allow us in order to return all the columns that deleted tuple from this relation. So it's going to allow us in order to return all the columns of the deleted tuple, okay, from this relation. So it's going to show you what the tuple is going to be deleted. Just display them. If you want to just specify the ID or whatever specific attribute, you can say I want to see only the ID, then after that the name, for example, or a specific attribute that I wanted to see the effect. How many tuples are going to be having affected? Then just show me the tuple use. It looks like delete this and this and this and this. And not for every single database management system. It's not related to the, the standard SQL. They didn't define this one in SQL. But this Postgres, I remember, they do something like this. Okay, some extra feature. Okay, back to the most important thing. I delete from instructor, just to give you the relation. Delete everything. I specify a specific condition. You tell me which tuple is going to be affected. When I say delete from, where condition here. Okay, and you can use whatever. You can use all the, for example, all the instructor with the salary between 13,000 and 15,000. Okay, we didn't have an instructor with this salary, but it's okay. Maybe monthly, I don't know. So anyway, delete from the instructor where the salary is between this value and this value. Okay, how about delete all the tuple in the instructor relation? For the instructor associated with the department located in the Watson building. So it looks like in this case, take a look at the query. What I need to achieve? Okay, I delete the list of the instructor where their department are located in a specific building. So in this case, let me take a look at the subquery here. It's going to produce all the list of the department that located at the Watson building. Okay. Then here in this case, I'm going to delete from the instructor where the department is going to be in this list. Can use, membership, set membership, and tested membership, set membership. In general, yes, whatever we learn, the SQL command or query that so far, we can use this one in order to specify which tuple or set of tuples that are going to be affected in order to perform this kind of manipulation. Okay? So delete all the instructor whose salary is less than, for example, the average salary of the instructor. So you can build a subquery, the average salary of the instructor. Then after that, I'm going to say delete star for whatever. By the way, you say delete from, Delete does mean, do you need to specify a specific attribute? No. Delete does mean the entire tuple. Okay? Delete from instructor where the salary is less than the average salary. Here, just I want to add one extra piece of information. The way that is going to be implemented is not the way that you're going to see for every single tuple I need to evaluate, I need to compute the average salary. So in this case, the database management system is going to do what? Compute the average salary from the instructor one time. Then after that, put this one as a fixed value, then you're going to evaluate based on every single tuple. Because if we don't do this one, so it's going to be a problem here. So if you evaluate this one every time after you affect this one for every single tuple, for example, the average salary maybe going to be 90,000. After delete one tuple, decompute this one again if we have a false implementation, which we don't have, thanks God. Maybe end up the average salary is going to be 80,000 or 70,000, for example. 70,000. So in this case, the data is going to be changed. Depends on the data is going to be stored here. But as you mentioned, the wise way in order to implement this one using the such command in the SQL, in general, or the database management system, compute the average salary first one time. Then after that, evaluate this one based every single tuple of the relation instructor in order to have an accurate result. So in other words, there is no recompute the average salary or testing of the total every time we perform this operation. Insertion. Can I do insert? Yes. I'm going to insert into whatever the tuple. The way they're going to perform this one, this is the syntax. I'm going to do insert. Okay, you have to give me enter. Delete from insert enter. And here you give me, for example, table name. Let's say table name. And here it's going to be optional. Maybe you can say, for example, actually, sorry, table name. It's not, optional. You're going to have the list of columns. And you can say here, very important values. And here you're going to be gives me the list of the values. This is the symbol of the syntax form of the inserting, let's say, a tuple into a relation. So specify the name of the table. Then after that, you can tell me, or you can specify the list of comma-separated columns. So you have the first column, the second, and etc. And the list of the columns is optional. It depends. We talk about this one in the beginning with the when you talk about the introduction of the SQL. Remember that we've said that it depends if you're gonna give the value of attribute based on the order of the, let's say, the column that's stored in this relation. So in this case, there is no need to specify the list of columns. Unless you're going to specify the order that for the value is going to be different than the order of how the data is going to be stored from the disk. For example, assume that you're going to store the value when you create the table. You have A, then after that B, then after that C. Or maybe you have ID, then the name, then the GBA. Now the value you're going to give me maybe the ID, then after that give me the GBA, then after that the third value is going to be the value. For the name. So in this case, you have to tell me the order of the relation or the attribute or column based on the order of the value that you need to specify. Okay? So both of them are the same. Then the value is going to be, in this case, comma-separated values. It's in parentheses. Okay? So you have a value 1, value 2, whatever. So here in the course, I know this is going to be the course ID, the name, and the department. This is here the total credits or the credits of this course, right? And if you have a value that's char, varchar, you have to put this one single quotes value. Okay? This one is equivalent. Both of them, they give me the same. The only difference here, I give you the list of attributes here, which we don't need it because I'm going to give you the first course ID name, the title, then after that the department, then after that the credits. Okay? If you try to add a new tuple to the student with the total credit set to null, which in this case, I'm going to give you null value. So this value is not going to be a specific value. So I'm not going to give you the null. Either going to be the value does not exist or the value is going to be null here. So in this case, you can say insert a new student into the student relation. Values, the student ID, and here we're going to student name, and the department, and the total credit is going to be null. This is one way in order to perform that. Okay? When you insert a tuple, you're going to see, notice that we're going to do this one using Postgres. The system is going to say something like reply or echo back or give me a result that says insert. Okay? And they give you like something like this. ID and count. This is the object ID, and this is count. Right now, when you insert anything, you know, for example, if you insert 5 tuples, the system gonna say insert echo back 0, 5. The count means that number of tuples gonna be affected. Number of tuples gonna be inserted in this case, 1 or 2 or 3. OID, which the object ID, which used to be used in the Postgres as internally, okay, as a primary key for tables, which allow us or allow the Postgres in order to figure out how could you internally represent or get access this tuple in the lower level. But no more they use this one. They don't use this one anymore. So right now when you perform this insertion, you see the first one, it's going to be 0, means the object ID is not given, or there is no object ID going to be used in this case, or given number, and he'll give you total number affected in there. Can I insert more than 1 tuple? Yes. At the same time. The way that we insert more than 1, you can say insert. Okay, enter, the same thing, relation here, and the values here. Give me the first one, comma, the second one, comma, the third one, okay? And the end, they have a semicolon. You can, value 1, value 2, value 3. So in this case, you can insert, for example, 3 tuple at the same time, at one time, okay? You don't need to say insert into value the first tuple. Then after that, insert into the relation, the values, the second tuple. You can do the insert into name of the table, if you want to specify the list of columns. Then after that, give me values one time. Then after that, put this one between parentheses. Okay. Once you do the insert, you can specify the returning value. The same thing that we did with the delete. This is just for the Postgres. So I need to double check with other database management system whether they offer the same feature or not. When you perform insert value into whatever value, you can say returning. Okay. What you need to return here. I can say start. When I say start or asterisk, that means it's going to return all the tuple that has been inserted. So it's going to print the first tuple, the second tuple, the third tuple. Okay? Or you can specify which attribute you need to specify. I think this is worth to play around when you're going to perform, let's say, try to test this one using the real database. Okay? Update. What do you mean the update here? Update, I want to modify, let's say, a column. An attribute, I need to change the value for, let's say, specific column here, okay? So we're gonna use update statement, and the update statement looks like something like this. You're gonna say update, the table name, okay? And you're gonna specify set, okay? And the set is gonna have this format. Okay? The set identity clause is gonna tell me, for example, which attribute that you wanna change, okay? So you need to specify the list of columns and their new values after the set keyword, okay? And the columns that you don't appear in the set class, it's gonna be return their original value here. So here you're gonna say set, okay? Attribute 1 is equal new value. That's what it, comma, attribute 2 equal new value, whatever the new value. This is the way how the attribute name and the new value for this attribute, and etc. Assume this relation, that relation R, that contains A, B, C, okay? If I said, for example, update R, okay? And the set, let's say A is equal, for example, 5 or whatever. Okay, done. When I perform this one, the system here do what? It's gonna change only the attribute A. How about the attribute B and C for every single tuple? This one I didn't specify which tuple is gonna be affected, right? So that means in this case, for every single tuple, the column A is gonna be equal to 5. So how about the B, C? Since you didn't specify the list of columns here within this set, so it's gonna return their original value. So the value P in column B and C for every single column is gonna be untouched. That's great. So allow me to, let's say, modify, let's say, one or more attributes if I want the value. And you can specify whether it's gonna be affected only one tuple or the set of tuples or all, to say, the tuple that we have in this relation. So that's why we're gonna use the where, the predicate or condition here. It depends on the where, it's optional. If it's not exist, that means you're gonna affect whatever you're gonna perform here, it's gonna be affect every single tuple of the relation. If you specify where clause, it depends now. Where clause or where condition here. There's a predicate that means in this case, I have full control which attribute, which tuple is gonna be affected using this update. Okay. So assume that you're going to give 5% salary raise to all the instructors. Yeah, I think I need to send this one to the president of the university. Just send them an email and say, please give us 5%. Usually give you 0.0000 something to 5%. I'm just kidding, by the way. I'm just trying to be funny, okay? I think it's better to remove this one from the recording. Otherwise, it's going to be this is the last time I teach this course. So anyway, assume that we give 5% salary raise to all the instructors. How can you perform that? For all of them. So I need to update the relational structure where what? Here, sorry, set the salary, the old value of the salary of that attribute equal, so the new value equal the old value multiply 1.05. This is the way how to perform that. You're going to take the salary, then after that give 5% extra for the salary. All right? If I said only give these guys all this raise for those instructors that earn less than a specific value. So in this case, I'm going to specify use the where clause in order to not does mean in this case not every single tuple can be affected by this query or this update. Okay. If I said give the raise only for the instructor their salary or whose salary is less than the average. So in this case, I'm going to say salary where clause less than, and you need to compute the average salary that we have here. Do you need to use as here as another attribute? I don't need this one because this one can be only used as a subset. It's going to be a result set of subquery, and use this one in order to compare comparison set with the salary. Okay. If I said, assume that we're going to give two different rates. Okay, we're going to say for the instructor, they're going to have their salary is greater than 100,000. We're going to give them 3%. And for the others, it's going to be give them a raise 5%. So that means if your salary is greater than 100,000, I need to give you 3%. Is that less than or equal 100,000, give you 5%. How can you perform this one? The order is important here. Okay? So I wish if someone do something like this. So you're going to give first, this is fine, give 5% to anyone less than 100K. Then after that, give 3% after that for anyone greater than, say, 100K. If in this case there's anyone, any instructor, their salary 95 or above, up to say 100K. If you give him 5%, this one gonna be go above, this one gonna be above 100K. All right. So it's gonna get raised 5%. Then after that, it's gonna get raised 3%. In total, 8%. It's not working like this. So that's why we said the order is important. Every time you do something like this, so start with the lower level. So start with the start with the higher level. Okay, start with the one their salary is greater than 100,000. Give them raise 3%. Then this was the first update. Then here I need to update for what? All the people their salary is less than or equal 100K. Give them raise 5%. So in this case, it's gonna be. I mean, this is the logic. How can you perform that? If you reverse the order, that means some people are gonna get 8%, which not the one that the university is looking for. I can do this one with simple way. Okay, we can simplify the process. I'm going to introduce you what is called, the case. One thing before I introduce you the case, when you perform this command or whatever kind of command, the system gonna apply or echo back using update or insert or whatever. I'm gonna say update, and here I'm gonna tell you the count, the number of tuples has been affected using this command. Okay, with the way that how the SQL is gonna echo back to us, tell me, or it could be like a kind of result, because when you perform update or insert or delete, we didn't expect to retrieve anything. We're gonna perform some action on the relation. Then we need to have some kind of feedback to tell us whether everything is fine, how many tuples has been affected, and etc. Okay, so it's gonna have with such kind of communication. This is the way how to interact with us. Okay, I'm going to show you the case. Case was this similar to the case statement that we know in the programming language. Just to use this one in order to make our life easier. So again, case expression is the same as if-else statement that we are familiar with in the other programming language. Okay, we can, so using the cases, looks like we can come up with using if-else logic to the query in order to form one interesting, or this is not interesting, this is a powerful query. Okay. So the case can be used where the select, where go by having anywhere, everywhere. Okay, you can use this one even with the select. Anywhere you can use select. So, sorry, case. How can you use the case? This is a general case. How can you use a case? I'm going to case. Okay, and here you can specify when. Give me the first condition. For example, whatever condition. Then after that, then I'm going to use C1 as a condition. Then you have result 1. We're going to perform something. Then the second one, you say when. We don't have F. We're going to use when. Okay. Then you have another condition. Then do something action or do whatever the value that you're looking for. Continue this one until you reach the last one. We're going to have else. You're going to, and here we're going to say the else result or the final result. I say else result. And once you have a case, you have to use end. So this is the way that you perform this one. You start from the top, okay? The first condition that's being evaluated the true, you need just to perform whatever the action, the result. Then after that, you jump after the end of the case. Yeah? So you start from the top, find the first condition that can be evaluated the true. Then perform whatever the result, stated the result here. What does else mean? Else actually, this one, the last one, is like by default, looks like the default value. Is optional. You don't need to perform that, okay? So what if all the condition here in the top, all of them evaluate to the false. So in this case, the system gonna say check. That means in this case, if none of all these conditions can be evaluated true, so in this case, I'm going to evaluate or kind of execute whatever comes after the else. So this is by the default values. None on the top is going to be evaluated the truth, then you have to execute here, this one. Okay? If we don't have else, and none of all of them is going to be evaluated the truth, the system is going to return as a null value for this case. Okay? So what I'm going to do here, I'm going to try to combine, since instead we have two, let's say, update statement in order to just to achieve give the raise for the 3% for the anyone over 100 for the instructor with the salary greater than 100 and all others by 5%. Instead we have two, I'm going to combine them in one update. And here based on what? Based on the salary. If the salary, for example, greater than 100,000, that means you have to compute the salary multiply 103. Else the salary must be less than or equal, multiplied by 1.05. Okay? So that's what we're going to do here. Update instructor, and set the salary equal here, case. When the salary is less than or equal 100,000, then the salary is going to be 1 multiplied by 05, right? Else, do you have another condition? No, else. So either it's going to be the salary is greater than 100, less than or equal 100,000, or the salary is going to be equal this one. Either of them, okay, for every single total. Clear? That's interesting. So this, again, is just summarize the syntax that just went over this one. Okay? Another thing, the last example here, assume that I wanted to give you the situation where we wanted to update the total credit attributes of each student. What's the total credit attribute for each student? The total credit attribute for each student in the student table that contains is what? The sum of all the credits. Of course, it's successfully completed by the student or the student. For example, you complete 3 courses, so your total credit will be 3 multiplied 3. Of course, it depends on the total or the number of credits, all the courses that you completed, successfully completed. How can you decide whether the course can be successfully completed or not? We're going to take a look at the grade. If the grade is neither F or null, that means this guy is going to be assumed that it's going to be the student successfully completed this class. Of course, I'm going to ignore the incomplete, in progress, etc. and assume that we have A, B, C, D, or F. Or no, this is the grades that we have. So in order to do that, I'm going to perform this one as the following. I'm going to say, okay, update the list of the student, or the student relation. Set the total credit equal the following here. I give a name, the relation name, as an alias, because I want to use this one. Set the total credit here for every single student from the original relation as following. You need to select the sum of the credits from what? The list of each course and the takes. Okay? Why you need to ask the takes and the course? Why I don't need to just get the information that I'm looking for the takes? Because I need to have the credit for every single course. The credit associated with every single course is going to be available only in the course relation. Here in the takes is going to have the course ID. So using the course ID is not enough, because I need to have what's the credit associated with every single course. Because some courses maybe have worth 3 credit hours, some of them 2, some of 4, some of 1. So I need to make sure that I'm in the right place, okay? Some of them 2 actually. So in this case, I need to have from total credit, compute the total credit from the takes and costs, make sure that the course ID is equal the course ID from the takes in order to get the credit of this course. And also I need to make sure that the student ID for this student that I need to compute the total credit from the outer row. Remember, for every single candidate tuple from the outer relation or the outer query, we're going to evaluate this one within the inner query. Yeah, this is correlates the subquery. So here I need to make sure that for every single course, this or the looking only for the courses taken by this student. We're gonna get the from where to get the student ID. I got this one from the candidate tuple that I expect is gonna be part of the result in this case. Okay, and also make sure the takes of this course dot grade is not equal F and doesn't or not null is not null value. How can you compare the not value? Please don't say equal null. Do this one. You have to use the special command that I gave it to you last time, where you're going to use is null or is not null. Okay. So this one, you're going to evaluate this one for every single tuple. If you have this one for every single course taken by the student, they manage to compute the total or the number of credits the student successfully completed. So in this case, we can update this one for the total credit of the student. This is one way how to do that, but we're going to see later, we're going to talk about the procedure, the function. We're going to show you that how can you write that the function now that take this one, it's going to be much easier. Okay? One thing we need to add here. How about what if, by the way, we have a student or set of students or any particular student who hasn't taken any course yet. So what's going to happen in this case is it's going to be null, okay? The credit is going to be, they say this, the grade of this course of this student that hasn't taken any course yet is going to be null. If you have a null, you can try to compute the sum, and all the courses taken by this student are going to have a null value of the grade. So in this case, we end up, we have the sum of the empty thing going to be null. If you have a null here, so in this case, end up, we have a total credit going to be equal null value for this set of students, right? I don't like to have a null as a total credit. I need to make sure that total credit either going to be value, numeric value, or going to be 0. I don't want it to have a null. So in this case, instead use the sum credit here. I want to change this one using what? This command. This one is going to be substitute the sub credit. So in this case, we're going to say when the sum of credits, okay, is not null, that means contains value, then return the sum credit. So it looks like here this total credit is going to be the sum credit. Else, the total credit is equal to 0. We're going to have full control. Allow me to avoid this issue in this problem. This is end of the chapter 4. So again, the midterm is going to be up to here. Okay? I talk about the midterm exam at the beginning of this lecture. I think both of you missed it. So the midterm exam is going to be Tuesday, June 22nd. And the exam is going to be from 6 p.m. to 8:30 p.m. And as I mentioned here, why I did this one? Because there are many students that are working from 9 to 5. Okay, so they cannot do the exam during their class time. So that's why the exam will be from 6 to 8:30. Okay, so you have 2.5 hours in order to finish the exam. Maybe you need less time. Okay, it depends. Okay, try to make sure that the exam is doable, easy to understand, easy to answer. Okay, so the exam is open book, open notes. Okay, and yeah. So it's going to be up to the chapter 4. So what I'm planning to do right now, remember I give you like a short, I talk also about the phase 2, okay, and phase 1 in the class projects. Hopefully, if you get a chance, I'm planning to send you the feedback for the phase 1 by the end of today. If that happens, or if it doesn't happen, for any reason, I think I'm planning to give you like an extra time to finish phase 2. I don't want you to finish phase 2 before you get like the feedback of the phase 1. Okay, so the current time the due date of the phase 2, I think Thursday, June 17. Maybe I can give you 2 more days to finish this one. I will try to give you the feedback for the phase 1 today, but if not, so don't worry. You do have enough time in order to finish phase 2. Okay? Questions? Yeah, I'm planning to give you another homework cover chapter 4 here. This homework, so the midterm exam, it's going to be similar to the question that we have in the homework. The one that hopefully gonna post it maybe today. I will try to do my best to be available today in the Blackboard. So whatever you have I'm keeping saying quizzes. We don't have a quiz in your class. Okay, so it's gonna be the homework 1, 2, 3. It's gonna help you in order to prepare for the midterm exam. You don't need to memorize anything. The only thing you need to understand to make sure that you have to understand the given schema. You have to understand the query, then try to do your best in order to write the query that answer. I'll give you the right answer. Okay? So this lab, I'm going to upload it maybe today, hopefully. This one, remember, we work with the university database and all the examples that we have based on the university database, yeah? So now I'm going to show you the step-by-step, how could you load, okay, the PostgreSQL that we have with the sample database. What do you mean sample database? You're going to basically create a database. Then within the database, I'm going to show you automatically how could you just download 2 files. One of them contains all the schema that you need to require in order to create your relations, which is the same one that I expect you to bring to me or upload to the phase 2. Okay. Then after that, I give you like another file. I'm going to show you exactly where you can find this line. Actually, if you follow this one, you're going to find the link with the database proxy.com. This is the link. How can you find the files that are going to allow you in order to download the files that you're looking for. The first one is the DDL, which contains, let's say, the relation schema, help you in order to create tables. I'm going to show you how can we use them. Then the second file is going to contain like a sample data, which is going to be, it looks like we perform many insertions in order to fill this relation with data. Then after that, you can perform the query that we have. Okay, the only difference here, you need to make sure that right now the data that we have in the class on the slides, we use, for example, 2017, 2018, etc. In this sample data, all the data can be 2007, 2008. Okay, so I will try to fix this one and upload let's say, if you want to use 2007, 2008 instead 2017, 18, it's fine. Remember we said the course offered in the fall 2017. If you try to prove this one, it's not working the sample data that we have right now because the data is going to be dated 2007 and 2008. I'm planning to modify this one, then I'm going to upload the file, hopefully today. I'm keeping say today, it looks like I'm not going to do anything today. Hopefully today, okay? I'm going to upload another file like this in the Blackboard. This one, I'm going to say new or whatever. This one allow you in order to populate your data with the data that has, or let's say, consistency with the format that we have in the class. So now we can say looking for the course offered in the fall 2017 or 2018 and etc. So anyway, if you follow this one, you can just load the data using the PSQL or the terminal or the shell. Okay, there's another way, easy way. You can do this one using what is called PG admin. Okay, with the graphical user interface, which allow us in order to work with the Postgres. Many database management systems offer 2 things. Allow you to use maybe just a command line or terminal or shell to access the data, PSQL, for example, that's similar to the Postgres. Or you can use a graphical user interface using the PG admin. I prefer to use the graphical user interface. And I'm going to show you the steps here. I will create a table, database. Then after that, I'm going to show you that how can we extract my data, or how can we find the data that I'm looking for, and how can you perform this one, okay? First, before do the PG admin, go to this link. I will give it to you here. Give me a second. I think I will push this one down so we can see this one in the Blackboard. For the student gonna watch the lecture later, I think I need to add this one here. For this link. Oh. Let's do this one here. Okay. So this one again, the link that contains the database or the text box that you work with. I talked about this one before, yeah? Let's try to switch this one. Let me share this one with you first, then after that you can use this one. Give me a second. That's what we got at the page that contains the text box, okay, that you work with, okay? So as you mentioned at the beginning of the first lecture, you can take a look to the solution to the practice exercise. If you click over this one, you can have some exercise related to the first chapter. If you have more exercise, that's good practice in order to help you in order to practice for the midterm. You can PDF here for the SQL here, give you like some commands that relate to the master maze in the university database, and not, of course, not the question will be available with the answer. So give you the same question, and this is the answer of each of them. So you can use this one in order to practice. It's a good practice to prepare for the midterm exam. Give you another database schema, then some questions. So something like this is going to great help for you in order to make sure that you understand the material. The other thing that I'm trusting here, there's another way you can use like run SQL query directly in your browser using the SQLite. I didn't use this one because I prefer from you to use Postgres. Okay, so here you can check. For example, this is the whole database that we have. The university database is already loaded with some sample data. And here you can write your command. You can say select star from, say, whatever, classroom. Okay? And you can execute your query here, which will give you the result that we have. Okay? Something like this. This is one way to do that. Or, this is the one that we're going to perform. Take a look at the sample data here. Here, if you click over this one, the sample data is going to show you many ways or different files you can download. The first one, data definition language, this file that contains here, if you try to use this one for the first time, you need to populate the data, create relations, okay, inside the database. Do this one. If you want to do this one again for the second time, you have to use the second one because the data definition language, the second file, that contains drop files. The first is going to delete all the files that we have, relations that we have, or tables that we have. Then after that, you're going to do what? It's going to create a new one. Okay? The second one, we have like, I'm going to give you the SQL code, which allow you in order to create the large relation. This one will have a sample relations. So this one, not too much files. This one, I guess, contains many files. So see that this is the formation. From the department, going to contains 20 departments, different departments. From the instructor, going to have a 50 instructor. For the student, going to contains information about 2,000 students. So that's what. So you download DDL, this one, and download this file. And make sure that we know exactly when you download. Now I'm going to show you that how can you use this one using the BG admin. Assume that you open the BG admin, okay? So once you open this one, you're going to have something like this, okay? So, of course, it's going to ask you about username, the password, with the password that you know that the one that you use in order to, the same one that you use when you install the BG or Postgres in your computer. In my case, 1, 2, 3, 4, and for simplicity here. The first thing you're going to do here, assume, in my case, we have different versions. I'm going to have this Postgres 13, the version that we have. When you click over this one here, the first thing you need to do here, right-click here, and create. And create, you have to create a blank, a new database. This one is going to be do it only one time. Just for simplicity, I'm going to create a weird database. In your case, create university. The name of the database called university, okay? If you didn't do this one in the first lab. So here, just say CS425. Let's do this one, yeah, since we're going to use summer 2021. Okay? And just use enter. You didn't need to create a name or to say owner, etc. For simplicity here, just we have go with the default here. Then after that, you have to search about your database that we have here. I call summer, yeah? Click over this, okay? Then after that, inside the database, you're going to see that we have different schema. Right now, we're going to use the public schema. Check the tables here. You're going to see there is nothing here. If you click here, there is nothing there. So it's empty database. Make sure that you are under whatever database that you create, okay? Then after that, go on the top here. You see this one? It depends, by the way, in the version that we have the BG admin on the Postgres that you download. This one we have what's called the query tool. I'm gonna click this icon here on the top. So here give me the query editor. I can write any SQL query if they want here. So in order to download whatever, fill this one, create tables, then after that, populate these tables with data, okay? Remember I said you need to download 2 files. Remember the DDL and the large data that we have? So just I want to make sure that, yeah, I need to know where I download them. Okay, assume in my case that we have it. So take the DDL SQL, just for example here, okay? You cannot see this one, but you're going to see this one using, it's going to be in the recording. Assume that your data is stored somewhere. Just click over the ddl.sql, then move this one and throw it inside this. It's like inside the query editor. So that contains, you take a look at what you have. You have just create tables, just creation. This is one file that I need from you to upload, for the phase 2. I need to have something like this. Then after you just drag and drop here, you need to do what here? You need to execute this one. You see this one, this icon here? That execute query. And it might be different from Postgres version to another, but I think the recent one you have something like this. When you click over this one, you see now we're gonna get, click, now execute the query and tell me that it's going to create tables, okay? If you want to make sure that whether the table has been created or not, remember, I'm inside the CS425 summer 2021, okay? If you take a look at the right click and click over refresh, this one you're going to see, oh, we have a table out there. It's going to be executed. It's already there. Take a look at the student. In the columns here, you're going to give me information about these data that's stored here. Okay? ID, this attribute. They are empty. Now, you can, for example, clear this one or create a new query tool, okay? Now take a look at the second one. Now you need to populate this one with data. In order to populate this one with data, you need to go to the large insert file SQL that we have, okay? That you download with the DDL. Drag and drop here in the query editor. And that's what you have. You see that? That have insert in the relations here. Okay? Now we need to execute. When you execute this one, it takes a few seconds, milliseconds, then after that, now we're going to say, now we execute, we fill this one with data. Once you're done with this one, you can clear this one or maybe open new one. Now let's perform some query. For example, select star pharmacy instructor. Execute. You see, now you give me the data here. You can select, for example, ID from the instructor. Give you the list of ID. You can say now, count the ID from the instructor. You're gonna give me the count here. Okay, something like this. You can as I say, count and say ID. And by the way, either you're gonna perform this one. Sometimes I prefer you do for every single line. You're gonna have one class. They'll be much clearer. You see that every time you write your query, you can execute this one. Give you the number that we have here. Okay, makes sense, guys. That's all for today. Thanks, guys.